Okay, today's notes we're going to talk about density. Density is mass divided by volume. Now, this little triangle right here is called the density triangle. I honestly, when I started teaching earth science, had never seen this before. Somebody actually pointed it out to me. It's very handy, but you have to draw it correctly. I just remember to put a T in it right there so that you know what to put where. If it's density equals mass divided by volume, this equation comes right off the front cover of your reference tables. Now, density goes in the bottom left, mass top, volume bottom. Now, what's handy about this is once you start knowing how to use this equation or this triangle, whatever you cover up, that shows you where they go. Mass over volume. Okay? Now, when you're trying to find the mass, if you cover up the mass, oh, they're not over each other now. Now they're next to each other. Density times volume. That's the bottom equation here. Okay? And when you're trying to find volume, you cover up the V, now you have mass over density, and you get that equation. There's also the ways of manipulating them around like you do in math, and you can do the same thing. But this is a little example that works very well. Now, density is how much material is in something, okay, the mass of it, but also with how much space it takes up. So the more dense something is, the heavier it's going to feel. A lot of people use the example that, oh, this is very dense because it feels heavy. Well, yeah, I mean, you could have something that feels really heavy and have something else that has the same weight, but it takes up a ton more space. So that's not really comparing the density, okay? You guys know that lead, for example, lead is very heavy for the size of it, okay? A ping pong ball is not very heavy for the size of it, okay? Differences in density. The ping pong ball would be a low density, and the piece of lead, like a sinker, for example, would be a higher density. Density is going to be using these units. Grams per cubic centimeter, because you're doing mass, grams, divided by the volume, and if you did like a cube, it would be centimeters to the third, because you do length times width times height. Now, sometimes you're going to have liquid, which that would give you milliliters. Graduated cylinder, beaker, examples like that. All right, now moving on. Mass. Mass is the amount of matter in an object, okay? It's the instruments that we use to measure mass are either a digital scale or a triple beam balance. Now, the triple beam balance, if you're trying to, or the digital scale for that matter, if you're trying to find the mass of a liquid, okay, you're going to try to find the mass of the graduated cylinder, find the mass of the liquid with the graduated cylinder, subtract them out to be able to get the mass of just the liquid alone. Okay? Now, many things, if you're trying to find the mass of a rock like you did in the lab the other day, you will just take the rock, put it on the digital scale or the triple beam balance. Now, the unit that we're going to use typically is going to be grams. Yes, you could use kilograms, you could use pounds, but, earth science and science in general, we typically use the metric system, okay? But it's the amount of matter in an object, okay? I have more matter than my son does, okay? My son's a few years younger than me, but I have more matter, okay? Now, moving on. See what you meant on that one, Mrs. Gates. They do slide better if you do it the other way. All right, volume. The amount of space an object occupies or takes up, okay? Well, I'll use my son and I again, okay? I take up more space than my son. Well, that would explain why I have a higher mass than he does, because I take up more space, okay? Now, instruments used to measure could be either the metric ruler, if you're doing length times width times height, okay? Or the graduated cylinder if you have like a rock or something like you had the other day. So the graduated cylinder would give you an answer in milliliters. Okay, and you do that by water displacement or volume displacement. You don't have to use water, but that's typically the easiest thing for us to come up with, so we do water displacement. Okay, but if you're doing the length times width times height, you'll get centimeters cubed, because it's centimeters multiplied by centimeters cubed. Okay, so that's the amount of space something takes up for volume. Now, does density change? Well, yeah, density can change if certain things happen to it. But what we're talking about is changing the size and the shape of the same material. So if I took a piece of the aluminum cube that you guys used the other day in the lab and shaved a chunk of it off, that is not going to be any different. We have a severe thunderstorm warning in effect. Anyways, so the changing the size or the shape of the material does not change the density of that particular material. For example, the aluminum cube. If I took this particular aluminum cube, which has a density of 2.7 grams per cubic centimeter, and cut that into 4 different pieces, each piece of the aluminum cube is still going to have a density of 2.7 grams per cubic centimeter right here, okay, even though it's in 4 different pieces. If I took these 4 pieces and cut them into smaller pieces, the density of aluminum is 2.7 grams per cubic milliliter, okay? The same thing if you think about it this way. A raindrop in a lake or, something along that lines, they have the same density. The density of water is 1.0 grams per cubic centimeter, or grams per milliliter, okay? It doesn't matter how much water. I could have a drop of water, I could have a glass of water, I could have a lake of water, okay? They all have the same density, okay? Now that's because you're comparing the mass and the volume, even though they might be different size objects. So, moving on, if you were calculating out the mass per unit volume, okay, the more mass something has, if we were talking about the aluminum cubes just a second ago, well, that's going to take up more space. So when you do that calculation, that's where you figure all that out. Okay? Anyways, moving on. Relative density. When an object is less dense than water, it will float. Okay, water has a density of 1.0, which I'll show you here in just a second. So if it's less than dense than water, it will float. A bobber floats. A piece of wood floats. Okay, it doesn't matter. I could take a log; it'll float. Okay, most of the time. I mean, it obviously depends on the different type of wood that you have, because different types of wood have different densities. Okay, but anyways, I could take a toothpick; it will float because it's a piece of wood. I can take a log, like I said, and it will float. But they don't have the same mass, but those two might have the same density. Okay, so if they're less dense, they float. An object that is more dense than water. Okay, I don't know why they call them sinkers, because, imagine what they do. They sink. Okay, when it's more dense than water, it will sink. Okay, that's why they call them sinkers. Okay, really tough name on that one. But anyways, when an object is the same density, and this is what confuses people a little bit, it's not going to go to the top, and it's not going to go to the bottom. What it'll do is it'll kind of stay right in the middle. So it will stay suspended. Okay? Yeah, it will suspend in the middle. Okay? Which I'll show you a diagram on this right now. And right there is the density of objects in water. So the density of objects in water, well, I just told you water has a density of 1.0 grams per milliliter, or grams per cubic centimeter. They mean the same thing. Okay? And if this is my beaker here, and right there's my water, filled up to that point, and all this under here obviously is the water. Okay? If I have something that floats, and I know this may be very tough for you to read, I'm going to tell you that says 0.7 grams per milliliter. Okay? So, if it's 0.7, okay, that is less than 1.0. So, it is going to float. Now, wait a minute. Does that mean the whole thing is going to be entirely above the water? No, some of it will be in the water a little bit, but floating just, it could be half in the water and half out of the water. But that is floating. It's considered less dense. Now, if it's the same density as the water, it has a density of 1.0 grams per milliliter. Okay? And that we call it in suspension. Now, they are the same density as the water. If something is more dense than the water, okay, it will sink. That right there is 2.5 grams per milliliter. Okay? And so it sank right to the bottom of the beaker. Now, here's a little bit of a tricky thing, because they like to do this on the Regents every once in a while, is they will show you a different liquid. Now, the different liquid might have a different density. Okay? Now, whatever the density of the liquid is, If it's less dense than the liquid that's in the container, it will float. If it is the same density, I don't care if it was a liquid that, mercury, for example. I don't know if you guys have ever seen mercury. It's in a liquid at room temperature. And, if it was the same density as the mercury, it would have a greater density than this. But if it was the same density as the mercury, it would stay right in that middle. Okay? And if it's more dense than the liquid, it's going to go to the bottom. Now, even if it's a different density than water. I hope this makes sense. If not, you better be asking us in class.